remember exactly if we learned this in 1010. It almost seems like we did. Didn't we do some logarithms in 1010? Yeah, okay. Because I was going to say, I swear, I can't remember because I know we did it in honors, but I just couldn't remember if we done it this year. So, did we do properties of logarithms also in 1010? The stuff we learned last time? Yeah, cool. This is good to have some review because once we get into unit, like, you know how we're finishing at unit 4, and then we jump into unit 10? Unit 10 is a little bit harder. Like, I'm not going to lie, 10.2, it's hard. So, it'll be good to have some easy parts like this one. So 4.5, we're going to be solving now logarithmic and exponential equations. Yeah, you're right. We did do this because I remember I stressed so much that with logarithms, we need to check for extraneous solutions, but not with exponential. So it's all ringing a bell. So these are the steps we take to solving a logarithmic or exponential equation. The first step is to isolate the log or the base to one side of the equation. So I'm going to do 2 examples at one time. So on my, I'm not plugged in. No wonder. On my exponential, the base is 3. You all agree? The reason the base is 3 is because that's the part that's raised to the x power. So, all right, so we got to get that by itself. So we're going to add 1 to both sides. Then we have base 3 to the x plus 2 equals 7. Agreed? Isolate the base. Now, same thing here. Isolate the log base. So we're going to add 1. So then we have log base 2 of x plus 2 equals 5. We've done our first step. Then the second thing is to undo the base or logarithm by applying the correct inverse. Now, just a reminder, to undo base 3 is not divide by 3, but it's log base 3, right? So then second step is to undo the base or the logarithm. So this would be a log base 3, undoes a base 3. So we have log base 3 both sides. So now on the left, log base 3 and base 3 undo each other because that's what inverses do. So we would have x plus 2 is equal to, now right now I have this, log base 3 of 7. Now just a reminder, shouldn't I probably do the change your base formula real quick with that log base 3 of 7 so that when I go to calculate it, I can use my calculator, right? So the change your base formula says I can rewrite this as x plus 2 is equal to what? Good. Good, log of 7 over log of 3. Okay, I wrote kind of small in there. Okay, awesome. So now we've done the second step. Let's do that same step here. Undo log base 2 with a base 2. So then log base 2 raised to the, base 2 raised to the log base 2 cancels out. So we have x plus 2 is equal to, now remember this is not 2 times 5. That's a base 2 raised to the 5th power, which is 32. And now we've done our second step. The third step is then to just solve for x using correct algebra. So why don't we just subtract 2? So we would have this. X is equal to log of 7 divided by log of 3 and then minus 2. That would be your answer. And then we would type it into our calculator. Over here we'd subtract 2. So x equals 30. So go ahead and grab your calculator and do that for me. And then I'm going to hurry and grab a decimal just for the video for me. Okay, now you get a 0.228 roughly. Does it go on further?
Yeah.
Perfect, we'll just go there. Awesome. Now fourth, we need to check our answers for extraneous solutions. Now people, listen. This should be able to completely click for you. It is, if you go back to the original problem, what would be the domain of an exponential? All real numbers. Remember, an exponential looks like this. It grows left and right forever. Therefore, we can input anything into an exponential equation. Therefore, it is not possible for this to have an extraneous solution. Now, with logs, that's not true. Can't we only plug in, not that we can only plug in positives, but inside of a logarithm has to be positive, correct? So if we plug in our solution of 30, is it going to be negative inside the logarithm? No, so we're good, so it's not extraneous. All right, are we good? All right, awesome. Let's go on. Couple more examples then. So solve. So probably a lot of these you won't even need to take notes on because you've seen this so many times. You'll just be able to know if you know what you're doing with the homework. So let's just all watch. So what would I do first? Divide by 8. So then I have base e raised to the 2x equals. Don't they both divide by 2? Let's get to it even better. You're awesome. Let's divide both by 4. So this would become a 5 over 2. So 5 halves. Now what undoes E? ln both sides of the equation. ln and E undo each other. So we have 2x is equal to, now we have ln of 5 halves. Can I split that up as ln of 5 divided by ln of 2? You're saying no, you're right. Why? Can you tell me why?
Well, because it's supposed to be ln 5 minus
Awesome. Remember, like, technically divide isn't just divide, right? When you divide, you subtract. Now we have an ln button on our calculator, so that's not necessary. Way to go. Way to think. All right, so not necessary. I was just testing you. Just testing you. Divide by 2, divide by 2. So then from there, please quickly type in that for me so I can write down. Let's just round in 2 decimal places. So ln of 5 halves divided by 2. Perfect, 0.458 roughly. Everybody good? Moving on to the next example. Okay, solve. So isolate the base, done. Then we would? Yeah, sure. Go ahead and do this one by yourself. Check your answers and tell me if I've made an error somewhere. If I wanted to check my answer, I'd probably write out the whole decimal, correct? And now couldn't you type in e to the 3 minus 2 times that entire decimal? And then it should be 4, yes. Now, would it ever be extraneous? No, because this is an exponential equation. Okay. All right, this one is just a reminder of how to solve this one. E to the 2x minus e to the x minus 6 equals 0. E to the 2x minus e to the x are not like terms. That's like an x squared minus x. We can't put them together. Any ideas of how we would maybe look at rewriting this to solve it in a better, easier way? Add 6? Okay, if we add 6, it's a good thought. Like, that's a natural thing to want to do. Say that again? Yes. Yes. So technically, I liked your thought process, but when you would have added 6, then you would have got stuck, because if you would have factored out an e, then you still would have had an e left inside, so that wouldn't have been very useful. So instead, just a reminder, look, these guys are noticing it's quadratic in form. Degree 2, degree 1, constant. That's quadratic in form. Our u substitution is e to the x, everyone, right? If this is supposed to be x, guys, then that would be our u substitution, because this would be u squared minus u minus 6 equals 0. Now we'll solve by factoring. Well, multiplies to be negative 6 and adds up to be negative 1. 3 times 2, negative 3. It quick factors to be u minus 3, u plus 2. But u's not u is e to the x. So we actually have e to the x minus 3 times e to the x plus 2. And now don't we set each of those equal to 0 and solve? So e to the x minus 3 equals 0. E to the x plus 2 equals 0. So solve for x. Solve for x. So what would I do? Add 3. So we have e to the x equals 3. Then we would ln both sides. So x is equal to ln of 3. Then we could type that into our calculator and get a decimal. Now over here, wouldn't we subtract 2? So we would have e to the x equals negative 2. Then we would ln both sides. ln of a negative. Can't. You can't do the log of a negative. Therefore, that is a solution we throw out. Now, this would be our only answer then. ln of 3, which is what decimal? Cool. So this was an example of one with technically an extraneous solution. Awesome. Well, it's just a solution we threw out. Okay. All right, so looking at this one is a little teeny bit tricky. So we have 3x e to the x plus x squared e to the x equals 0. I would write this one down for myself. Now, it's not quadratic in form, is it? There's a lot more stuff going on in there. So there's something that we might take into consideration here. I don't know. Don't we usually solve things by factoring if possible? Yeah, I'm hearing people say take out e to the x. Yeah, even x e to the x. Okay, so let's pull out and see if that helps us at all. So let's pull out x e to the x. So then go back and divide by x e to the x. Divide by x e to the x. So then left in my parentheses, x and e to the x divided out, so 3. Then plus sign. X squared and x divide out, so don't we just have x? And then my e to the x's divide out. And then we have equals 0. So now, don't we set each of those equal to 0 and solve? Okay, let's think about this. Now guys, careful here. Here's what I'm going to talk about. These are different factors. Does everyone see? So we actually have to set 3 things equal to 0. So we have x equals 0, e to the x equals 0, and we have 3 plus x equals 0. We have 3 factors technically. Now solve for x. X equals 0 is already solved for. What will we do here? ln both sides. So x is equal to the ln of 0. Now if you try to type it into your calculator, try it. Domain error. Well, why? Can anyone think of why? Yeah, there's a vertical on logarithms. There's a vertical asymptote at 0. Can we be 0 inside a logarithm then? Nope, we can't be negative and we also can't be 0. So we throw that solution out. Then we would subtract 3. So x equals negative 3 is our second solution. 0 and negative 3. Yeah. Or 0. No, the ln, we didn't take a logarithm here. It's not that the original, does that make sense? Only when we're solving if a logarithm has a 0 or negative on the inside. I see the question. That was a good question. Now, and then also make sure that you understand that just if you're solving a logarithm equation, you can get a negative answer as long as when you plug in the negative into back of the original that it's not negative inside the logarithm. Does that make sense? Okay, all right, solve this. So 2 ln of x minus 4 equals 6. First step. Add 4, then we would. So ln of x equals 5, because you added 4 and got 10, divided by 2 is 5. Now undo ln e. So ln and e undo each other, so x is equal to base e to the 5th power, and decimal is what? Say it again. 148.4. Yeah, so and you'll make sure you just use the E button on your calculator because we don't want to round too hastily or we'll be off. Okay, awesome. Now look, is that a potential problem for our original ln problem? No, it's not negative. Would we be plugging in a negative inside a logarithm here? No, so we'd be good. Okay. All right, log the base 2 of 25 minus x equals 3. Go ahead and solve this one by yourself. X equals 17. Now I'd go back, plug it in to the inside of our logarithm. 25 minus 17, is it negative inside if I plug in 17? Nope, so all is good. Now just a reminder, make sure with these type of problems you isolate the log before you undo the log. So if there would have been a plus 1, like out on the outside of this parenthesis, you would make sure you got rid of that before you base 2'd both sides. All right. So let's look at this one. Write it down. This one's a good one to write down. 4, 3 log of 2x equals 16. Well, I guess this one's still pretty straightforward. First step would be to subtract 4. Then we have base 3 log of 2x is equal to 12, right? Then we would divide by 3. So we have log of 2x equals 4. Then base 10 both sides. So we have 2x equals 10 to the 4th. Good. Then we would divide by 2. So x is equal to 5,000. Awesome. All right, so looking at this one, everybody, let me just show you what you absolutely cannot do. You have a log of x plus 2 plus log of x minus 1 equals 1. People think, once again, that they can go, I'm going to base 10, base 10, base 10. And I've done it to each piece of the equation, so all good. Not true. That's equivalent to base 10ing across a plus sign is the equivalent of like squaring across a plus sign. You can't do it. So how are we going to make it so that there's only one logarithm? Combine them, yes? How? Good, yes. When you add, you multiply. So this is log of parentheses. We have x plus 2 times x minus 1. When you add, you multiply. Very good. So that's equal to 1. And now it would be appropriate to base 10 both sides. So now our true statement is this. X plus 2 times x minus 1 equals 10 to the first, which is 10. Now this is a quadratic. Don't we need quadratics equal to 0? Well, if that's the case, then we need this in standard form. So that's what I'm going to do first. So I'm going to multiply this out. X squared minus x plus 2x would be plus x. Then we have a minus 2 equals 10. So shouldn't I subtract 10 over? Yeah. X squared plus x, and then minus 10 over would be minus 12 equals 0. So now you'd solve by factoring. Well, multiplies to be negative 12 and adds up to be 1. 4 and 3, negative 3. So this quick factors to be x minus 3, x plus 4. Therefore, my solutions are x is equal to 3 and x is equal to negative 4. Now, careful because we got to go and check. If I plug in 3, will it make it negative inside the parentheses? No. If I plug in negative 4, will it make it negative inside? Yes. So that's extraneous. So our only solution is 3. All right. Okay. Doing good here. We're winding down to the end of the lesson pretty much, so let's just keep going. What would you guys do? Base 2 both sides. True. So then that undoes that, and we would have x squared minus x minus 2 equals? 4. Good. That's not 2 times 2, but 2 squared, which happens to be 2 times 2, so that's 4. So then x squared minus x minus 6 equals 0. It multiplies to be negative 6, adds up to be negative 1. So it factors to be x minus 3, x plus 2. So x is equal to 3, x is equal to negative 2. Now, don't just assume that all negatives aren't going to work, right? Let's plug it in and see if it's still negative inside. So if I plug in 3, is it going to be positive? Yes, right? 9 minus 3 minus 2. All right, let's plug in negative 2. Negative 2 squared is 4. Then we have minus negative 2, don't we? Minus 2. So isn't that 4 plus 2 minus 2, which is 4. Is it negative inside? No, so that's not extraneous in this one. Awesome. All right, winding down here one more time. Could I base 5, base 5, base 5? Nope. We would have what true statement? Log base 5 of? Good. Is equal to? You could subtract that over and then you could divide, but that's going to make it actually a little bit harder because what can I do now? Base 5 both sides, can't I? So we have x times x plus 1 equals 20. So what would I do now? X squared plus x minus 20 equals 0. And then you would solve by factoring. Let's just quickly keep going. What multiplies to be negative 20 adds up to be 1. 5 times 4, negative 4, right? X plus 5, x minus 4 equals 0. Therefore, x equals negative 5, x equals 4. Do I need to throw out either answer? Negative 5? Because when you plug in negative 5, it's a negative inside the logarithm. Awesome. All right. Go ahead and try this one by yourself, please. Answer? So your answer is? No solution. So we subtracted 5, right? And then we had negative 2, 1/4, base 1/4, x minus 2 equals 10. Divide by negative 2. So then we have base 1/4 is equal to negative 5. Oh, sorry, base 1/4 raised to the x minus 3. How do we undo bases of fractions? No different, right? Log base 1/4. That's not a big deal to us. Log base of 4th. So now we would have x minus 3 is equal to log base of 4th, like this, log base of 4th of negative 5. And right there's the no solution part, correct? Let's pretend it was positive. What would be my next step? Change your base, which would be log of 5 over log of a 4th, right? And then from there. Okay, awesome. No solution. Very good. Couple last examples here. We're right down to the end. Okay, our story problems are just going to be pretty plug and chug-ish. So let's just read some and make sure we can see how easy they are. So it says if I naught and I denote the intensity of light before and after going through a material, and x is the distance in feet the light travels in the material, then according to the Beer-Lambert law, negative 1k ln of I over I naught equals x, it says, where k is the constant depending on the type of material. It says in part A, solve the equation for, I can't remember what it wanted us to solve for. I didn't write that down apparently. I think it was solve for I. What does part B ask for? Find the light intensity. Yeah, I think it told us to solve for I. Yep, it did. So let's pretend like it said solve for I. Okay, so get I alone piece by piece. Let's use algebra to get this I alone. First step, anyone? Math doesn't change just because there's variables. I like the idea, but what's an even easier algebraic step to take to get rid of negative 1 over k? You can't add because it's multiplied. Times by k, correct everybody? Won't that be easier than having to flip and multiply in the end? Does that make sense? So I'm going to times by negative k to both sides. Because now look, these divide out, don't they? So then I have, rewrite your problem, ln of I divided by I sub 0 is equal to negative xk. Next step, e both sides. So then we have I divided by I sub 0 is equal to base e raised to the negative xk, then yep, times by I sub 0. So I is equal to I sub 0 e to the negative xk. Perfect. Now it says, okay, for a certain where k is equal to that, and the light intensity I sub 0 is 14 lumens, find the light intensity at a depth of 20 feet. So now it's just plug and chug. So I is equal to, I sub 0 was 14, e is e, x was 20. So that would be negative 20 times, and our k was 0.025. So let's type that in and see what it comes out to be. 14e. I get 8.5. Awesome. So it wasn't necessarily that the math was any harder, it's just it does take a teeny bit of thinking. All right, last thing to note here. It says the sum of $5,000 is invested at a rate of 5% per year. Find the time required for the money to double if the interest is compounded semi-annually and continuously. Now, you have to remember for interest, there are two formulas. You're going to have to keep those memorized for this next test. So if it's compounded continuously, isn't that the PERT one? Y is equal to P times E raised to the RT. If it's not continuously, it was Y is equal to P times 1 plus R over N raised to the NT. Now we have to read this very carefully. A lot of you did not read the last test carefully enough. You just assumed that P was what they gave you because that's what you see a lot, but that's not always what it's going to be. So it says a sum of $5,000 is invested at a rate of 5% per year. So this one is, the put in is 5,000, yeah? Now it says find the time required for the amount of money to double if the interest is compounded in these cases. Okay, so our put down amount is 5,000 in this one. Do you agree? 5,000. Then we have our 1 plus our rate is 0.05 n semi-annually 2. So 2 raised to the 2 times t. Agreed? Now how much was in the end? 10,000. Didn't it want to know how long till it's double 5,000? How much time? So in the end, we're going to put in 10,000. It goes without being said that that is double. Now solve for t. What would be my first step? Divide both sides by 5,000. So I'm going to write up here. We have 2 is equal to. Now wouldn't it probably be easiest to actually find out what that is, that base? So 1, I typed that into my calculator and I got 1.025, agreed?
Yes.
And that's raised to the 2t. Solving for t, what would be my next step? Don't be that person that divides by 1.025. Yes, log base 1.025 both sides. Log base 1.025. So now over here I have log base 1.025 of 2 equals 2t. So don't I need to change your base formula? So that would be log of 2 divided by log of 1.025 equals 2t. So then won't we divide by 2 after that? So now you'll type in your calculator log of 2 divided by log of 1.025. Hit enter. Divide by 2. It's going to take 14.03 years for the money to double. But if it's compounded continuously, how much do we put in? 5,000. E is E. Our interest rate is 0.05, isn't it? Then T is T, and then in the end we're looking for 10,000, aren't we? So now solve for T here. You divide both sides by 5,000, won't you get 2? 2 is equal to base E raised to the 0.05t. Get rid of E. ln both sides. Then divide by 0.05. Divide by 0.05. So we have ln of 2 divided by 0.05. 13.9 years. The time it will take, if it's compounding continuously, is 13.9 years to double. All right. That's the end of the lesson, so the rest of the time is yours to work on the homework.